Please get the list.
All right, so today's lesson, we're doing 9-1, radians, degrees, and trig functions. Today's date is Friday, January 31st, 2020. Our objective, we actually have two of them today. What are they, Lorraine?
Convert between radians and degrees, find the trig ratios of right triangles.
There they are. All right, so let's talk about what a unit circle is, first of all. I'm going to be using the word unit circle over and over and over for the rest of this unit, and it's really important to know what the heck I'm talking about. A unit circle, before I talk about unit circle, let's talk about a unit square. A unit square is a 1 by 1 square, the most basic square I can give you. Therefore, the unit circle is the most basic circle I can give you. The radius, therefore, should be what with a quiet raised hand? A unit circle is just a circle with a radius of, Ellery? 1. Everyone go ahead and draw a center of that circle, draw a radius, and say that is a radius of 1. Or you can say on the top of that, r is equal to 1. Or a radius of 1. What's kind of interesting is to think about what the circumference is. So back from geometry, I taught you what the formula for the circumference is. Oh yeah, Cheyenne, can you please shut your laptop? A circumference, what is the formula for a circumference? Anna?
Pi r squared.
Ooh, that's area. Area is pi r squared. India?
2 pi r.
2 pi r. Everyone write it down. 2 pi r, which means if I plug in the fact that radius is 1, my circumference on a unit circle, so I'll say this is specifically for a, let me zoom in here so you can actually see what I'm writing. This is for a unit circle. A circumference on the unit circle is 2 pi. Which means if I were an ant walking around the edge of a unit circle, I would be walking 2 pi units, or roughly 6.28 units, because that's double pi. Question, Anna?
Yeah. Why isn't like r involved in the second one?
Great question. Someone else answer it. Why is there no more r in the circumference? Beverly?
Because the unit circle has a radius of 1, so you would just plug 1 into that, and it just 1 times something else is the something else.
Precisely, yeah. Thank you. All right, so I'm going to be talking to you about radians today and converting between radians and degrees. But before I even teach you how to convert, or I've already taught you, before we review on how to convert between degrees and radians, it's kind of important to know, what does a radian look like? Can you point to something that says, that looks like a radian? Well, now you can, because you can look at the notes. Each of these is a radian. Each of these pi slices. And you'll notice that there are not a even number of pi slices. I randomly have this tiny slice. So what's going on here? First of all, how many degrees are there in a full circle? If I rotate a full circle, I have done a how many degree rotation, Brian? 360. And this is one of those review questions I'm hoping at least one person can answer. How many radians do I move around when I rotate 360 degrees? Caroline? Good guess. That's in degrees. Ellery?
Is it 2?
It's really close to 2.
3? 2 pi.
2 pi, yeah. 2 pi radians is a full rotation. I'll move that out of the way so people don't hit their cards on it. Again, the distance of the circumference, or the distance that I travel in terms of the radians, is 2 pi. So if I actually do the math out here, I can say on my calculator, 360 divided by, in parentheses, 2 times pi, and I get 57.29577, or roughly 57.3. So I come out here and say this is approximately, I can maybe do approximately equal to 57.3 degrees for 1 radian. And it feels really weird to me as a mathematician to write radians, because radians are the one unit that is unitless. Which means if I don't write units down here, I assume that it's radians. So writing the word radian makes me cringe, because if I don't write anything, you assume that it's radians. But we also know, I put this down here just so that you know 1 radian is 57.3 degrees. You can visualize what that looks like on a circle. Does anyone have an idea why an even number of radians don't fit on a circle? Shouldn't it be like 10 radians are on a circle? Shouldn't it be like 5 radians are on a circle? Anna?
pi is like 3.14. It goes on.
That's really the answer here. Guess how many radians are in a circle? 2 pi of them. So if I do 2 times pi times 57.3, then that will add up to the whole 360. So this extra little bit happened because I have something like 3.14, that extra 0.14. Okay, the main thing that you need to know for the homework is how to convert from degrees to radians and how to convert from radians to degrees. So, given anything, and this anything is in degrees here, I'm going to leave it as box. Whatever that degrees was, I'm going to multiply it by pi over 180 degrees. This is the ratio that came from up here. I just simplified this to 180 degrees divided by pi. I divided the top and bottom by 2, and it's the same ratio. I took the reciprocal of that because this ratio evaluates to 1. You can even write over here on the notes that pi over 180 degrees, that's equal to 1. 180 degrees over pi, that's also equal to 1. By multiplying by this pi over 180 right here, we're not changing the value, we're changing the units. The angle is still the same angle. If I'm talking about pi over 2, boom. If I'm talking about 90, boom. It's the same angle, just in a slightly different form. All right, alternatively, you can convert from radians to degrees. So we assume that whatever this box was degrees. Whatever this box is radians. What do I multiply by in order to get it into degrees? With a quiet raised hand. I need someone to help me out here. India again. It is indeed 180 degrees over pi. All you have to do is take the reciprocal of your fraction. The way that I remember these is, what do I need? Whatever I need, I'm on the top. So this pi is in radians. The pi was on the top. I want radians. We'll make sure that the radians is on the top. If I want degrees, the degrees should be on the top, 180 degrees. Whatever I want needs to be in the top of that fraction, the numerator of that fraction. So let's try one out. I have 135 degrees. I want to convert that to radians. This is almost exactly what you'll see on Khan Academy. How do I do that? Well, I write down 135 degrees, and I'm going to multiply that by some fraction right here. Which fraction do I use? Do I use pi over 180 degrees or 180 degrees over pi? Give it a 50-50 shot of getting this. It's a new quiet raised hand. Who still has their card? Sam. It is indeed pi over 180 degrees because I want radians, so radians goes on the top. Another way of thinking about it is I need to get rid of the units of degrees. So one needs to be on the top, one needs to be on the bottom in order for those to cross cancel the units. All right, so from here, I have the new fraction, 135 pi over 180, because I canceled out the units of degrees and degrees. Now I need to simplify that fraction. Because if Khan Academy allows you to have a calculator, you can actually just simplify this online. But let's simplify it by hand first, and I'll show you the shortcut if you're using a calculator. The long way, divide the top and bottom by some number. Is there a quiet raised hand? What is a good number to divide the top and bottom by? Cheyenne. What can I divide the top and bottom by? Five. Perfect. So divide the top and bottom by 5, and I get a new fraction. So I know that 100 is 20. So 5 times 20 is 100. Now you need an extra 35, so an extra 7. So 27 is what happens when I do 135 divided by 5. You could have, of course, done it with long division. And then 18 divided by 5, that should be 36. So I still have the pi on the top. And then I have to do some more division. Does anyone see what's divisible, the top and bottom? Another quiet raised hand. You have your card. Beverly, go for it. 9. Divide by 9, divide by 9. And we get 3 pi divided by 4, and that is our final answer. How would I do this using my calculator?
What was the answer, sorry?
3 pi over 4. If I was using my calculator, and what time do we get out of here? Am I low on time? Oh, I got 17 minutes. Okay. So on my calculator, let's zoom out just a tad. I'm going to ignore the pi and just enter this. So on your notes, please just circle or box the 135 over 80. That's if you want to do the calculator shortcut. Ignore the pi temporarily, and we'll add that back in at the end. So 135 divided by 180. And it says 0.75, which doesn't help you, but check this out. This button right here says, make this a fraction. Convert to fraction, 3 over 4. It will do the simplification for you. So I come back here, I do 3 over 4, and then add the pi back in because I didn't include that. Many people make the mistake on the calculator of typing 135 pi over 4, and there's no ability to turn that into a fraction. So the way to do that is get rid of the pi, turn it into a fraction, and then add the pi in later. All right, let's convert 5 pi over 3 into degrees. So rewrite it, 5 pi over 3. I'm going to multiply by a fraction. What is that fraction? With a quiet raised hand. Do you have your card, Jane?
Yeah.
Yeah, go for it. Wait, you do?
Yeah.
Okay, go for it.
I'm assuming that we do, is it 180 over pi?
180 degrees over pi is correct.
I turned in my card, so now I answered my question, so now it's really in.
Okay. Thank you.
Just doing the right thing out here, that's what I do.
Thank you. I appreciate it. All right, so notice that I have a pi on the top and a pi on the bottom. They're going to cross cancel. They're gone. And I have to do some more cross canceling. I could do 5 times 180, but that's kind of a hard thing for me to do in my head. But I can say, what is 180 divided by 3 right now? Well, I know 18 divided by 3 is 6. So 180 divided by 3 is what with a quiet raised hand? We'll give it to Aurelio. What is 180 divided by 3? 18 divided by 3 is 6.
6, there you go.
180 divided by 3, therefore, must be
I don't know.
6D. Add a 0. All right, thank you. I'll take your card. Put you on the spot. And then finally, I have this number left, 60 left, and I have 5 left, so I have to do 60 times 5. Well, 6 times 5 is 30. Add on the extra 0, I get 300 degrees.
Crazy, bro. I'm so hyped to know this.
All right, so that is the first homework assignment. That assignment is on Khan Academy. The second assignment that I have for you right now is on paper. These go really, really fast. You can knock out this paper assignment in probably under 5 minutes. But first, you have to remember Sohcahtoa.
I don't even know her, dude. I've never seen her in math.
Write down Sohcahtoa to help us out. Capital S, O over H. So, Ka, A over H. And Toa, T-O-A. Write out Sohcahtoa. It is very helpful to remember because it basically tells you what your trig function ratios are. So as a review from Algebra 1, whenever I have sine, cosine, or tangent, those are ratios. Ratios of a triangle. Of this triangle, to be exact. Since I'm talking about this triangle. This triangle, let's just arbitrarily say my angle is right here. I could have made my angle up here. It would change some things. Let's say my angle of reference is in the bottom right. If that is my angle, what is my hypotenuse with a quiet raised hand? Is it 1, 2, is it 1, 2, or 3? What is the hypotenuse? Quiet raised hand. Who's got this? Yes, Chewy. What is the hypotenuse? Is it 1, 2, or 3? Say it louder.
There is no one.
It is 1. So this is the hypotenuse. Everyone label it. Hypotenuse. If I want to abbreviate that, I can just say HYP. HYP. Hype. What is the opposite? Another word for opposite is across. What is across from this angle? Is it 1 or 2? Quiet raised hand. What is the opposite? Oscar, yeah. Not quite. It's all the way across from the angle, so therefore it's 1. Yeah, it's opposite. I'll take your card. And the way that we abbreviate opposite is just with OPP. And finally, the adjacent. Adjacent, another word for adjacent is next to, and that's this down here. Adjacent. And I'll write A, D, J. And I'll put, I should change that to green. I'll put what the synonym is for opposite. Opposite means across. So if you don't like opposite, you can think of across. I can spell across. And if you don't like the word adjacent, you can think of neighbor. N-E-I-G-H-B-O-R. There we are. All right, so sine, according to Sohcahtoa, is O over H. O is opposite. H is hypotenuse. This needs to be opposite divided by hypotenuse. What about cosine? Quiet raised hand. What over what for cosine? Use Sohcahtoa. I'm looking for people that still have cards. Who has a card? Emily, yeah. It is indeed adjacent over hypotenuse. Thank you. I'll take your card. Who else still has a card? Leo, tangent. Careful. So Toa, look at your Toa right there. O and A.
Look at your toe.
Opposite over adjacent. Thank you. And just as a reminder that this letter right here is called theta. In parentheses, you can call this theta.
Theta?
Or in quotes. That's called theta. So I say sine of theta is opposite over hypotenuse.
What is theta?
Theta is a Greek letter.
Oh.
My lowercase Greek letters are up there by Chewy. I have a capital and lowercase. I highly recommend memorizing the uppercase Greek letters if you go to fraternities and sororities, because that's how you will identify them. All right, so
Identifies the same.
coming down here to example number 3. I need to find the following values. What is sine of this angle right here? Well, it's going to be opposite over hypotenuse. But what are the opposite? What is the hypotenuse? What is the adjacent? Let's label these things. Quiet raised hand. What is 4? What is 5? What is 3? I think everyone's in now. So Beverly.
Hypotenuse is 5, adjacent is 3, and opposite is 4.
There it is. You should be able to label all of these on your own from here on out. All right, quiet raised hand, first come, first serve. Now, since everyone I believe is in, if I forgot you, I apologize. Ellery, sine of theta is?
4 over 5.
There it is, 4 over 5. Because it is the opposite over the hypotenuse. So, O over H. All right, ka, for Sohcahtoa. What is cosine? Sam?
3 over 5.
It is indeed 3 over 5, because it is adjacent divided by the hypotenuse. And finally, tangent of theta is what, Brian?
Well, right.
3. No, like 4 over 3.
4 over 3. There it is. Thank you, Brian. That's how fast they go for the homework as well. You just have to make sure you're labeling your opposite and adjacent correctly. Let's try one more where the angle is now moved. Angle is not in the bottom right anymore. It's in the top. I don't know who that was, but did make me smile. Let's keep our language appropriate, though. All right, if this is my angle, what is my opposite? What is my adjacent? What is my hypotenuse? Quick hand. Who's got it? Ellery.
8 is opposite, 15 is adjacent, and 17 is hypotenuse.
She has it correct. Make sure that you have them all correct like her. Hypotenuse is 17. Hypotenuse is easy because it's the diagonal one. Across from our angle is our opposite. Across from the angle is 8. All right, so we've labeled these all correctly. Thank you, Ellery. And then rapid fire through these. Sine of that theta is what over what? Try to do this from memory as much as possible. Samantha.
8 over 17.
Sohcahtoa is 8 over 17, yes. Thank you, Sam. What about cosine? Cosine is what, Beverly?
15 over 17?
15 over 17. And finally, tangent is what over what? Beverly again.
8 over 15?
It is 8 over 15.
Give me some food.
And we're done with the notes. All right, there are 2 parts to the notes. The second part was doing these trig values, the trig ratios. Can you find those fractions? And then the first part was, can you convert between degrees and radians? Give me a fist of 5 for our objective really quickly. Go. Fist of 5. How well can you do this? 4, 4, 4, 5, 4, 5, 4, 5, 5, 4, 4, 4, 3. All right, thank you.